Okay, good evening, everyone. Today we'll discuss about probability. The means the topic of probability comes under data science. We'll come to a basic level of probability discussion. Okay. So I don't have my slide, but I will show you from internet sources. Okay. That you have already learned in your 12th class. Okay. So the probability. Uh, there are different terms like dependent and independent events. Okay, events and dependent and independent events, and then okay, then there is mutually exclusive events. Okay, and we'll discuss on conditional probability. Okay, so now for the timing, let's discuss basic fundamental of probability. Okay, see, uh, dependent events are the events that just see this dependent event where what happens depends on what happened before. Okay, so dependent events means before, suppose you are tossing a coin and uh, it is not a dependent event because every time you are tossing the probability will remain 1 by 2. Okay, because it doesn't depend how many times you have already tossed the coin. Okay, so that is not dependent. So but dependent events are depends that depends on the previous events. Okay, such as taking cards from deck makes less card each time, like when you are taking some card from the card deck, then every time you are means taking a card, then the total sample space is reduced by one. So see, the independent events are not affected by previous events. This is an important idea. The coin doesn't allow it come up with heads before, and each toss of coin is perfect isolating things. Okay, so it may be a fair coin. There are chances that the coin may not be fair. That means both the sides may be head, or both the sides may be tail. But fair coin always have both the sides means printed differently. One is tail, another is head. So these are the terms. Okay. So example of probability, as you know, the total probability is added up to one. Okay, so you toss a coin and it comes off heads three times. What is the chance that the next toss will also be head? So the chance is simply 1 by 2, just like any toss of coin. It doesn't depend on the previous occurrences, the previous events. So that's why it is independent event. So the syllabus covers dependent independent event, conditional probability, and Bayes theorem. So we'll discuss all these three in today's class. Okay. So just see some. This is a very simple thing that some people think it is overdue for a tail. That's why they are always expecting a tail when they are tossing the coin. But really, truly, the next toss of the coin is totally independent of previous tosses. Okay, and probability of independent events is how likely something is to happen. that is the number of way it can happen, the total number of outcomes. So this is exactly the probability of an event happening, total number of way it can happen. Suppose there is only one head, actually in a coin there is a one head, so that's why the number of way it can happen is one, and total number of outcome is two, so that's why 1 by 2 we are considering. Okay, so this is the example, and here just see the probability of getting 4 or 6 when rolling a die. The number of way it can happen is we are expecting 4 or 6, so 4 uh, there is a two number of outcome from the event, and total sample space is 1 2 3 up to 6, so that's why 2 out of 6, so 1 by 3 is equal to 0.33. So this is the probability, as you know, as a basic fundamental of probability. So here is another example. The probability of getting a head when tossing a coin is 1 by 2, or you can turn this as the turn it in terms of decimal values, or it can be in percentage values, or you can also say in terms of 1 in 2. Okay, so just see, we can calculate the chance of two or more independent events uh, by multiplying the chances. Probability of three heads in a row. For each toss of coin, a head has a probability of 0.5. Just hold on, I will take the marker. Okay. So here, probability of three heads in a row. For each toss of a coin, a head has a probability of 0.5, that is 1 by 2. And if you are tossing three times, then you have to multiply three times 0.5, that is 1 by 2, 1 by 2, 1 by 2. So exactly, so the total probability is 0.125. So 1 by 8 is it is 1 by 2, no, 1 by 6, 1 by 6 it is. So it is 0.125. Sorry, 1 by 8, 2 into 2 into 2, so 1 by 8. So, so each toss of a coin has a probability 1 by 2 because it is independent. So that's why it is 1 by 2 always. It is not affecting with the previous event. Okay. For each toss of a coin has a 1 by 2 chance of being head, but lots of head in a row is unlikely. White is unlikely to get say 7 heads in a row when each toss of a coin has a 1 by 2 chance of being heads. Okay, this is an example because you are asking two different questions. What is the probability of 7 heads in a row? So 7 heads means you have to multiply 7 times 1 by 2. So this is exactly 1% chances. Question 2 is when we have just got 6 heads in a row, what is the probability that the next toss is also head? So it is exactly 1 by 2 because it is not a dependent event. As the previous toss doesn't affect the next toss, so that's why the seventh event will also have probability 1 by 2. Okay, so this is the thing you have to know about dependence independent event. Okay, so we use P as the notation for probability of, okay, for the independent events. Probability of A and B equal to probability of A into probability of B. Okay, okay. Suppose this is the example. This is for independent. Your boss randomly assigns everyone an extra 2 hour work on weekend every evening, weekend evening between 4 and midnight. So you have to find 4 to 6 is the midnight time. So what is the probability? That is 2 hours extra out of 8 hours. So 2 by 8. Okay, so this way you have to calculate again. If it is a Saturday, then you have to means multiply these two events. For two events, it is probably 0.25, and if it is a Saturday, then out of Saturday event is if it is a Saturday out of two means it's a weekend. Weekend starts from Saturday and it's also Sunday. So 1 by 2 is the probability. So 1.5 into 0.25 is exactly 0.125. So that is a chance probability. Okay, so because here we are trying to find out the probability of both the events happen simultaneously. Okay, okay. Let's see some other example. Okay, So these are the outcome, the sample space of event when you are tossing a coin, tossing three coins simultaneously. It can be all three are coins will give you heads, or it may be one of them is tail and remaining two are heads. This is the combination. So this is how many? So eight number of combinations are there. So like the binary values, you can consider this as means 000. This is 100, like that. It is 111. Okay. So now let's define the following events. Getting no head, you have to calculate event A. Getting no head is how many? What is the probability of getting no head? So there are only uh, one case where head is not there. So 1 by 8 is the answer. Okay. Similarly, you have to calculate getting exactly one head. So one head is that is 1, 2, 3. Okay, 3 by that is 8. So this way you can calculate. Okay. So as you know, the probability events will range from 0 to 1. It will not exceed 1 according to the rule of probability. Okay. So let's discuss one more thing over here. Okay. So this is about all we discussed till now. That is about independent events. That means it is not dependent on the previous event that is occurred. Okay. So one more type of event is the dependent event that I just told you that when you are swapping or taking one card from the card deck, then it is dependent because it depends on the previous event to occur. So here is an example of independent event. A woman pocket contains two quarters and two nickels. So these are some coins in US. Okay, the two quarters are two coins, and these are different types of coins. She randomly extract one of the coin and just read this problem. She randomly extract. Okay, she randomly extract one of the coin, and after looking it, replaces it before picking a second coin. So when you are considering the replacement case, then it is then these are called independent. Okay, because you are replacing the previous event whatever is occurred. So let's Q1 be the event that the first coin was quarter. Okay, and Q2 is the event that the okay, Q2 is the event that the second coin is a quarter. Okay, so these are two events we are considering. The question is whether Q1 and Q2 are independent events or not. Okay, since we first the first coin that we selected is replaced, whether or not Q1 occurred. Okay, if it is occurred or not, that doesn't matter. Okay, has no effect on the probability the second coin will be a quarter. Okay, second coin will be a quarter or not, so that doesn't depend on the previous one because we are using this replacement policy over here. In either case, when she is selecting the second coin, she has in her pocket, so therefore the means probability of event 2, that is Q2, is equal to, there are two nickels and two quarters are there, so it is 2 by 4. Okay, regardless whether Q1 has occurred or not. So probability of Q2 doesn't depend on Q1. Okay, so now let's see another example. A woman's pocket contains two quarters and two nickels. Same example. She randomly extract one of the coin, and without replacing it back her pocket, she picks a second coin. As before, let Q1 be the event that the first coin is a quarter. Okay, so the let the first coin be a quarter, and Q2 be the event the second coin is a quarter. Okay, uh, this one is a first coin is a quarter, second coin is also a quarter. So what is the probability whether they are dependent or independent? Because we are not replacing it in the second when event 2 is occurring, event quarter Q2 is occurring, then Q1 has occurred and it doesn't replace the one which she has taken from the pocket. Okay. Just see here, since the first coin was selected is not replaced, whether Q1 occurred doesn't affect the probability the second coin is a quarter. Okay. uh, is not replaced, whether Q1 occurred doesn't affect the probability of second coin is a quarter. Let's see if Q1 occurred. Okay, Q1 is that is nickel. That is Q1 is about just I told you it is about Q1 is quarter and Q2 is in the same quarter we are taking from the pocket. Women's pocket contain those these two type of coins. Okay, and just see the second time when we are extracting or taking the woman is taking the coin from her pocket, then what is the probability of occurring that it is a quarter. Okay, first time it is 1 by there is 2 by how many were there, 4, so 2 by 4 was the answer. Now second time when we have considered that it is not replacing, then at that point, so the total number of sample space is reduced by 1. So earlier it was 4, so now it is reduced by 1, that is 3. So that's why out of number of coins already one is extracted in the event 1. So second time it is extracting, there is only one means possibility is there to extract to take this quarter. So 1 upon 3. So that's why there are three number of sample size is 3. So 1 by 3. Okay. So similarly, however, if Q1 has not occurred, then when the woman is selecting the second coin, that means if in the first event the woman has not taken the means quarter, then the quarter will remain in its own place. Instead, she has taken a nickel in the place of quarter. So earlier the sample size was 4. Now also it is earlier in the in previous to happening the event 1 it was 4. After that it became 3 because he has taken one nickel from the pocket. Then the sample size is reduced to 3, but instead of the total number of quarters means reduced to 1, so now it will remain same, but the size of nickel will be reduced to 1. So the probability will be 2 upon, because there are already two quarters available in the pocket, so that is 2 upon total number of size is 3. So that's why the event 2, if it is not happening, that it is not able to take this quarter in the previous event, so it is 2 upon 3. Okay, so now just see one more example. Two people are selected simultaneously at random from all people in the US. Then B1 be the event that one of the people has blue eye. Okay, just you see, two people are selected simultaneously and at a random from all people in the United States. Let B1 be the event that one of the people has blue eye, and B2 is the event that the other person also has blue eye. This is a there are how many number of people are there in the US, that is not mentioned over here, but we are being asked whether these two events are dependent or independent. In this case, since is this audible to everyone clearly, or any noise is going on? Is this audible? Yes or no? Okay, 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 okay. Let's continue because I'm getting some messages in the WebEx interface itself. So that's why I asked. Okay, see, because we are selecting two people randomly from the US, let B1 be the event that one of the people has blue eye, and B2 is the event that the other person also has blue eye. In this case, since they were chosen at random, Whether one of them has blue eye has no effect on the likelihood that the other has also blue eye. Therefore, B1 and B2 are independent. Means there may be a chance that we are selecting B1, a person who is in the event B1, we are getting a blue eye person. Second person is not dependent on the previous person, because there may be a chance that all people are having blue eye, so they are not dependent, so they are independent. Okay. On the other hand, if you will say one example, a family has four children, okay, two of whom are selected at a random. Let B1 be the event that one child has blue eye, okay, B1 be the event that one child has blue eye, and B2 be the event that the other child has also blue eye, okay. In this case, B1 and B2 are not independent, since we know that eye color is hereditary. Okay. Thus, whether or not the child is blue-eyed will increase or decrease the chance of other child has blue eye, respectively. That's why it is these are not independent. Okay. Just see the means probability rule. If you will have this is called multiplication rule of independent events to calculate probability of A and B. Okay, when these two events A and B are independent, then we have to multiply probability of A and B equal to both event A occur and also event B occur. So that is this is in the Venn diagram itself. We can show you it in this place. That means this is the place where both A and B occur simultaneously. We will see some example regarding in what case that both the events can occur simultaneously. Okay, so maybe somewhere it is. I will show you. Otherwise, okay. This example is also fine. Yes. So see, probability. This probability rule 6 it says that okay. If A and B are two independent events, then probability of A and B equal to probability of A into probability of B. Okay. This rule you have to remember, that if both the events are independent, that means A doesn't depend on B or B doesn't depend on A, then we can multiply the two probabilities if it is given. We'll solve some problems. I have some problems with me. We'll solve it. Okay. When dealing with probability rule, the word and will always associated with the operation multiplication. Hence, the name of the rule multiplication rule. Okay. So there are. I have some other example instead of this. Let me come to that. Okay. Okay. I'll come to that multiplication rule later. But for the timing, just see. Uh, okay. This is conditional probability. We'll discuss this one. But before that, maybe somewhere it is. Okay. Just come to here. Addition rule for probability, then we'll come to multiplication. A single six-sided die is rolled. What is the probability of rolling a 2 or 5? And getting a 5 or 2, what is the probability? So there is a or symbol in between. So the number rolled can be a 2, the number rolled can be a 5. Okay. So that is 2 upon 6. This is 5 by 6, that is once it will happen, so that's why 1 by 6, this is also 1 by 6. The probability of means getting a 2 when we are rolling once, means that is 1 upon 6. Similarly, this one is also 1 upon 6. These events are mutually exclusive since they cannot occur at the same time. This is one more term you have to remember: mutually exclusive. Whether means if two things can occur simultaneously, so that will be called as not mutually exclusive, but it is called mutually means if it is not happening simultaneously, so that will be called as mutually exclusive. That means the in the Venn diagram we can show you that in terms of like this. This is one event and this is another event, and this is called A. Or event A, this is event B, and there is no common place in between, so that's why it is called mutually exclusive. Okay, and now come to this is that means if 2 will happen, then there is no chance of happening 5. Okay, so the addition rule, when two events A and B are mutually exclusive, the probability that A or B will occur is the sum of the probability of the event. So it will be 1 by 6 and again plus 1 by 6. So it is the calculation has been done over here. A single six-sided die is rolled. What is the probability of rolling a 2 or 5? Rolling a 2 or a 5. So that is one of getting the probability of 2 is 1 by 6, probability of 5 is 1 by 6. So it is the addition because there is a symbol or we are using in the event. Okay. So what is the probability of getting a 2 or a 5? Okay. So this is one more. A spinner has four equal sector colored yellow. Okay. Blue, green, red. What is the probability of landing on red or blue after spinning in the spinning this spinner? Okay. So probability of red is 1 by 4. The four chances are there. Similarly, blue is also 1 by 4. So total is 1 upon 2, that is 50% chance. Okay. Okay, come to here. A single card has chosen at random from a standard deck of 52 playing cards. What is the probability? As you know, total number of cards is 13 into 4, that is 52. And so that's why the total sample space is 52. What is the probability of choosing a king or a club? That means we have to calculate, just see whether this is mutually exclusive or not. Okay. So because here it is not mutually exclusive because a card and a club means this one is the club. Okay, and a king means this K is king. If you are aware of this card game, those this is for them. So this is club and this is king. So what is the chance? This symbol, the small symbol is over here. So that is a club. Okay, so probability of king or a club, that is we cannot add it directly. We can add, but we have to subtract the common thing happening in between. So that is because here it is not mutually exclusive. Okay, this is non mutually exclusive. The event 4 are not non mutually exclusive. In addition case, the kings of clubs to be counted twice. Okay, so its probability must be subtracted. So its probability must be subtracted when two events are not mutually exclusive. Okay, a different addition rule must be used. Okay, that thing you have to remember. So earlier we have added only the two things when it is not when it is mutually exclusive. But in the case of non-mutually exclusive events, we have to subtract the common things because a king can also come in club group. Okay, so there are four groups of card. Okay, so in every group means king is present. So we have to subtract because we need king as well as club. So there is only one chance that a card can be king or a club, means both king and a club. So that's why 1 by 52 chance the probability is for a card to be king and it is also a club. So we have to subtract this much from the total probability. So it is 4 by 13. So that is the exact probability we need to calculate. Okay. So here is also another example. Okay, when two events A and B are non-mutually exclusive, the probability of A or B will occur is probability of A or B is you have to subtract the common thing when both the events which are happening simultaneously, that one you have to subtract. So this is in terms of Venn diagram. You just see if it is mutually exclusive, it is not mutually exclusive. There are some events happening over here that will means that thing you have to subtract in terms of when you are adding the two events. So you have to subtract this much. Okay. So this is another example. In a math class of 30 students, 17 are boys, 13 are girls. So let me draw. So in a class of 30 students, 17 are, so this is the total sample space. Okay, in the Venn diagram, means superset. That is, students, boys are there and girls are there. Okay, so four boys and five girls are girls made a grade A. Okay, so let me put somewhere like this. Okay, so this is for boys, this is for girls, and so there are some people in common in between. Okay, means some boys are there. That means it's not boys and girls. It's okay. So uh, on the units test, four boys and five girls made a grade A. So A grade, and this is not A grade. Okay. So there are some girls or boys. There are four boys and five girls. Okay, five girls. Those who performed excellent and got a grade A. If a student is chosen at random from the class, what is the probability of choosing a girl or a grade student? That means a girl and a grade student. That is a mutually exclusive. That is due to which this one and means a girl can also get probability the grade A. So that's why we have to subtract that probability from here. Okay, because the girl and this grade A are common over here. Okay, so that's why you have to subtract 5 by, because there are five chances. So 5 by total number of students is 30. So probability is 5 by 30. So you have to subtract that much. Okay, these two things you have to remember. If it is mutually exclusive, then addition rule one: when two events are mutually exclusive, the probability that A or B will occur is the sum of events A and B. Okay, but when A and B are not mutually exclusive, that means there is some common events occurring in between. So there is some overlap between these two events. The probability of A or B will occur is the sum of the probability of each event minus the probability of the overlap. Okay, so this thing is the important factor we are subtracting when it is not mutually exclusive. So that you have to consider by judging what type of event is happening. Okay, so just see. Uh, okay, so these are some other things you just go through. Let's come to one more topic, that is called conditional probability. Okay, so conditional probability event can be independent, meaning each event is not affected by the other events. Okay, independent means suppose you are tossing a coin, then it is not dependent on the previous event that I discussed just some time before. Each toss of a coin is a perfect isolating thing. What That's why it is being used when we are playing game and we are choosing who will play fast. Okay, who will bet, who will bowl, that, like that. Okay, so what it did in the past will not affect the current toss. Okay, that's why the chance is simply 1 by 2, so that is 50%, just like any toss of coin. So each toss is an independent event. So let's discuss about some events that are dependent, but events that can also be dependent, which means they can be affected by previous events. Suppose there is a example, here is a box available where three red balls are there and two here it is taken marbles. Okay, these are three marbles red and two marbles blue. Okay, total number of five marbles are there. So what is the chance if you means of getting a? So the question is, but after taking one out, the chances change. Okay. So the next time when we get a red marble before the chance of blue marble, next is 2 by 4. So at the beginning when we are means expecting a blue ball, so we have to take one. So the chance of getting a blue ball out of the whole sample is 2 upon 5. But after the first event has occurred, when you are extracting means from the remaining, so it is 1 upon 4, because already we have taken a blue marble. So that's why the sample space has been reduced. So out of 5 it became 2, and out of 2 it became 1 because the blue has been reduced because you have taken one blue ball in the previous event. So that's why if we got a red marble before, then the chance of blue marble is 2 by 4. Okay, in this there are two chances are available. Two types of event may happen. Maybe in the first event you may get a blue marble, or you may not get a blue marble. Okay, so when you are getting a blue marble, then the means it will affect the next event. Okay, the first event is two upon 5, but in the second state, second event may happen like this, that it depends upon the previous one. If the previous one has taken blue ball, then the probability is 1 by 4. If it has taken a red ball, that is 2 upon 4, because you have kept this blue marbles in its own place. So that's why this one is 2, and the total number of sample space is 4. Okay. So this one will be reduced obviously because you are taking one. But whether you are taking blue or red, that affect the next event to occur. Okay. This is because we are removing marbles from the bag. So the next event depends on what happened in the previous events. So this is called dependent. Okay. So next we'll show you that using tree diagram. Okay. If you replace the marble in the bag is, then uh, changes do not uh, chances do not change, the event are independent. Okay, if you replace, so this thing you have to remember, if you are replacing that, then it will not affect on the next event to occur. So it will remain as it is, like 2 by 5, like the head tossing, the coin tossing event. Okay, so with the replacement the event are independent, and without replacement the event are dependent. So this thing you have come across, that just this is a revision of your schooling mathematics. Okay, dependent events are what we are looking here. Just see, there are means what will happen. Just see in this diagrammatic manner, in this tree diagram. It is a wonderful way to picture what is going on. So let's build uh, one for our marble. Okay, this tree diagram. So there is a 2 by 5 chance of pulling a blue marble from the whole sample. So that's why it is 2 by 5. Okay, so two blue marbles by, we are expecting two marbles out of two blue marbles, where the sample size is 5. So 2 by 5. So it may be chance that we will not get okay, here this is 3 by 5, because you may get if you are interested for getting a red marble from the box, then it is 3 by 5. So this is for blue marble probability, this is for red marble probability. So we can go one step further and see what happens when we pick a second marble. Okay, after happening after this event has occurred, so what is the probability of getting another blue marble over here? So that because we have taken one blue marble, so that's why the remaining marbles are 4, but out of them the total possibility is decreased by 1. So total, earlier it was 2 blue marbles, now it is decreased by 1. So total number of blue marbles probability is 1 upon 4. Now this thing happened 1 upon 4 because this depends on the previous event what has occurred. If you have not taken a blue marble over here, then it will be something different. It may be 2 by 4. Okay, so similarly if you want to take a red marble, then it also depends on previous event, whether something has been extracted from it or not. So that's why it is 3 upon 4 instead of when 3 upon 5, it is 3 upon 4. Total number of sample size was 5. But now because of this event has occurred, the sample size decreased by 1. That's why 3 upon, instead of 5, it is 4. Similarly, if you will this means if you will expect that red ball to happen in the means outcome, then it is 3 by 5. Okay, so instead of 2, because there are two possibilities here, the possibilities are 3, so 3 by 5. So after this event will happen, then the total sample size is reduced to 1, that is 4. So next blue marble size probability is different because we have taken a red marble. So that is 2 upon 4. Okay, because this thing remain intact. It is not changed. This blue one is not changed right now. so it is remaining as it is, so that's why 2 upon 4. Okay, similarly this is 2 upon uh, 4 again, because we have taken one red marble in the previous event. Okay, so now if a blue marble was selected first, there is a now a 1/4 chance of getting a blue marble that we discussed. These two lines discuss about that. Now we can answer the question: what is the chance of drawing two blue marbles? So it is a 2 upon 5 chance followed by 1 upon 4 chance. Okay. So if it is the question, what is the chance of drawing two blue marbles? First we have to draw a blue marble. Next time in the event 2 we have to extract another blue marble. So this event will give you a probability 2 by 5, and this event will give you a probability 1 by 4. So this is 1 by 4. The first event is 2 by 5. The probability of getting a blue marble out of the whole sample, this is 2 upon 4. Now it is being changed in the second event. It is when the number of blue marbles reduced to 1, so that's why 1 upon 4. So the total probability of drawing two blue marbles are, that is 2 upon 5 into 1 by 4, because these events are dependent events. So that's why you have to multiply these events. Then you will get 1 by 10. Okay. So this is regarding how dependent means events probability is calculated. The chance of getting two blue marbles is 1 by 10. Okay. Okay. Next, you can also go through this one. Here, similarly, this is 1 by 10, and probability of A and B both occur. That is over here. Okay. So A is a means getting a blue marble. B is another event. A is one event. The first event is called A event. The second event is called B event. So that thing we can means write like this. It will be called as one type of. It is called conditional probability. And here means this is read as you can read it as probability of B given A. That means you have to calculate the probability of B when A has already occurred. So that probability you can calculate by multiplying the previous probability, the probability of A, and this event probability. You have to multiply these two. So that is 2 by 5 into 1 by 4. Okay. So that is 1 upon 10. So that same thing you will get. So this thing is called conditional probability also, and this because this is for dependent means events. So that's why the conditional probability is calculated like that. Okay. Now drawing two cards, two kings from the deck. So event A is drawing a first king, event B is drawing a second king. Okay. The first card, the chance of drawing a king is 4 out of 52. Okay. And there are 4 kings in the deck, as you know. So that's why 4 upon 52. But after removing the king from the deck, uh, the probability of the second drawn card is less by to be okay to be the king. That means the king size has been reduced to 3 from 4, and similarly the number of cards is also reduced. So that's why the probability is 3 upon 52, 51, and the total sample size is also reduced. Okay. So the probability of getting a drawing a king, and the second time also there is another king you want to take from the total sample, then it will be 4 by 52 this one, and this one is 3 by 51. So that's why you have to multiply these two. You will get 1 upon 2 to 1. So that is the probability you will get. 1 upon 2 to 1 is exactly almost. So the chance of getting 2 king is 1 in 2 to 1. So or about 5%. You just calculate how much it is. Okay. So it will be giving some 0.5 something, 0.05 something. Then you multiply 100. That will be give you some percent. That is 0.5%. It is not 5%. This is 0.5%. So that's why it is not 1 by 2. This is 1 by 2 to 1. Okay, it will give you that much of fraction value. Okay. So now this is called conditional probability. When event we have to calculate the probability of b when a has already occurred. Okay, so that is you can calculate using this formula, that is and is you can say probability of a and b, that we can write like this: probability of, okay, a and this, that is intersection b. So that is you can calculate and you can put over here. So this formula you can remember like this: every time the conditional probability is calculated, you have to put over here the intersection of the things which are available over here, a and b intersection, and division by whichever is given. This is given to us. Okay, so this can we can also read it like probability of b given a. So this one you can read it as given. Okay, given. Okay, so the probability of event b given event a is equal the probability of event a and event b. So this is intersection divided by the probability of event a. So this thing you can remember, that whichever is coming uh, as a given thing, that probability you have to divide at the denominator. Okay, so we'll discuss base theorem with this conditional probability. Let's connect. Okay, let's see if it will be automatically disconnected, then we'll again connect. Okay. Okay. So this example, just see 70% of your friends like chocolate and 30% like chocolate and like strawberry. Okay. So what percent of of those who like chocolate also like strawberry? This is the question, and the given data is 70% of your friends like chocolate and 30% like chocolate and strawberry. That means intersection is given 35%, and chocolate is let it be a. Okay, so let it be a. So this is a Venn diagram over here, and this is called this is 35% is given, and the 70% is for chocolate, let it be a, and b is 35 instead of b is not given. Okay, but a is given 70%. Okay, so we have to calculate probability of b, probability of B or probability of strawberry given probability of chocolate. Chocolate is given and you have to find the probability of strawberry when chocolate is given. This is read like this. Okay, so that is you have to find, apply the formula, that is conditional probability formula, probability of chocolate and strawberry. So that is 35% division by probability of chocolate. This one is given, that's why you have to put in the denominator. So that's why 0.35 by 0.7, so that is 50% chance you will get. Okay, so this is how the percentage is calculated. You can get this one directly. Okay, so 50% of friend who like chocolate also like strawberry. So okay, these are some other examples. I will send you the link, you can go through. Okay, let's disconnect and try to reconnect again.